Okay, so today, joining Geeta Chauhan, who leads AI partnership engineering at Facebook AI with expertise in building resilient, anti-fragile, large distributed platforms for startups and Fortune 500s. As a core member of the PyTorch team, she leads TorchServe and strategic partner initiatives for building a strong PyTorch ecosystem and community. She's the winner of Women IT in Silicon Valley, CTO of the Year in 2019. She's also an ACM Distinguished Speaker, and she's a thought leader on topics of ethics in AI, deep learning, blockchain, and IoT. And she's passionate about promoting the use of AI for good in the field. So this talk will cover topics of how to deploy your AI models, best practices for different deployment scenarios, and techniques for performance optimization and scaling and ML at scale. So please join Geeta for to learn about these topics. Thank you very much.
Thank you, Ali. I hope everyone can hear me. So I'll just project my slides and we can go over. Okay. So welcome to the talk on scaling AI in production using PyTorch. My name is Geeta Chauhan and I lead the PyTorch partner engineering at Facebook AI. So today we will cover what are some of the big challenges with ML deployment in production. Then we will look at the TorchServe high-level overview and walk through some of the best practices for production deployment. So before we dive into the production aspects, so I wanted to briefly share that PyTorch is growing very rapidly across the community. So if you take a look at the trends from papers with code, you will notice that more than 54% of all new papers in the ML space are published with PyTorch as the primary framework. And we are seeing contributions from large companies besides Facebook, so Microsoft, Google, Amazon, Tesla, Disney, a lot of companies are contributing. And the ecosystem is growing, and we welcome you to contribute into the PyTorch as well. So let's look at some of the challenges for the deployment of ML in production. So ease of use, performance, cost efficiency, and deployment at scale are some of the major concerns that you have to tackle when you deploy your models into production, especially around the inference for scale. When you are deploying and managing models in production, it is quite challenging. You have to worry about loading and managing multiple models. How do they serve? What servers they get deployed on, end devices. How can you run a pre-processing or a post-processing of the prediction request? Is it happening in a batch mode or a real-time mode? How do you log and monitor and secure your predictions? And all of a sudden, like if you are in a environment like retail where your workload just hits a peak, how does your services automatically scale and handle that? So all these are big pain points that people have to deal with when you're deploying your models into production. So we built TorchServe with keeping all these considerations in mind. We wanted to have a solution which was easy to deploy for large-scale production deployments. So out of the box, we provide default handlers for common machine learning tasks. There is a low latency for the model serving, and it works in any ML environment. And we've done integrations across environments across the industry. So this is what the structure looks like. You will typically do a HTTP request for running your predictions into the TorchServe. You'll call the prediction API. There is in addition to the prediction API, there is a management API and a metrics API. And behind the scenes, when an inference request comes in, it will serve the model and send back the requests. When you are ready to deploy a particular model, you take your PyTorch model, you package it into what we call a model archiver, along with any dependencies that are needed, and you bundle and deploy it using the management API. And once that is deployed, then your model is ready for serving. So as I mentioned earlier, we provide default handlers for common use cases. like image segmentation, text classification. Uh, we also have the option to do a custom handler. So if you're writing your own models, so let's say you're doing a Hugging Face BERT or a multimodal or any model where you need to put in your custom logic, you can use the custom handler. We provide a model zoo where you can quickly get started out of the box by taking some of the pre-created models, and you don't have to worry about having a starter MAR file created. You can just reuse from the model zoo. The TorchServe supports multiple model deployments on the same TorchServe instance. It has the ability to version your models. You can roll back to a previous version of a model. If you're doing batch inference, we have support for automatic batching. We support both HTTP and gRPC as interfaces. And all the common logging and metrics, all that is available. And you also have the ability to do custom metrics. And there is a robust management API. So let's dive into what a handler looks like. So out of the box, we have the default handlers. There you don't have to write any code, and you can use your model. When you're writing a custom code, this is what the structure looks like. So there is an initialize method where you would load your model, and if you are doing any custom steps, like in the case of a NLP model, you need to load vocabularies. That is what you would do in the initialize method. And then pre-process is where you would be doing the pre-processing and the transformations of the data before the inference. And inference method is where you have any custom logic for the predictions. And post-process is where, in case you need to do any post-processing after the inference and before the data is sent back on the wire, you will do that. Handle, you don't really need to override. It's here for reference. Then this is the model archiving utility. It is a CLI tool for packaging all the model artifacts into a single deployment bundle. So you invoke the Torch Model Archiver, you give a name to your model, you specify a version number, and you give your model file and the handler. So handler is needed if you are doing eager mode model serving. If you have a Torch scripted model, then you don't need to supply the handler because all the details are there along with the model itself. And if any extra files that you need, like vocabs, etc., you can bundle those. For dynamic batching, we have parameters that control this. So when you are deploying your model in the config, you can specify the batch size and the max batch delay. So the batch size controls how much is the maximum number of batch that will be dynamically created, and batch delay is when it cuts off. So let's say you had a batch size of 8, you got only and a batch delay of 10, and you had only 4 requests coming in 10 milliseconds. So then those 4 will be sent as a batch and processed. And then for the metrics, out of the box metrics are provided. You can, so this includes the CPU, disk, memory utilization. There is also a TS metrics class that you can override for extension. So you can do things like, add your own metrics for distance in km, or you want to have a size specific, you want to capture the size of the image as a metric, or you want to capture some additional loop counters. So all that you can do through the custom metrics. And all this is integration with the Prometheus is available. So you can get the details from Prometheus and Grafana. And some of the recent features that we just launched as part of our 0.4 release, we added support for ensemble model support. Captain model interpretability was added a little bit earlier. We have just launched the integration, full integration for PyTorch with Kubeflow pipelines with end-to-end examples for computer vision and NLP, which includes the integration with KF serving for the TorchServe side, along with the auto scaling and Canary rollout. So the great thing is this works both on-prem and on any cloud. So it gives you a common way of doing things in any particular environment. We also integrated this with the Google Cloud's Vertex AI serverless pipelines. So there you can just pay per use, and you don't have to spin and manage your own cluster environment. We have integrations with MLflow. I mentioned the Prometheus integration with Grafana. And on the Amazon side, all the EC2, SageMaker, EKS integrations are there with auto-scaling. And there is also support for AWS Inferentia chips for the AI accelerator. And in the 0.4 release, we added new examples for multimodal neural machine translation and Deep Lab v3. So please check those out. So now let's take a step back and look at what are some of the best practices for deploying your models into production. So you need to, like, before you even start building and thinking about your ML application, you need to think about the responsible AI elements right at the beginning. So, similar to how one does security by design in the traditional software space, you will now need to look at fairness by design. You're making sure that your models are human-centered by design, and you're taking all these considerations into mind. So this is where you would start at the design before you even think of having your models ready for production deployment. Then once your model is trained, you will need to look at the optimizations. So these are very important from a deployment perspective. So here you need to have considerations for performance versus latency. You will do things like profiling with TorchScript to see if TorchScript is giving you better performance. You will want to do some cost benefit analysis of whether you want to do offline versus real time. And you will also do the cost analysis of whether you should be deploying it on a AI accelerator chip like Inferentia or something else. Then how you actually deploy it, that's captured in the deployment models. So when you start your development, you will be doing it standalone. Initial rollout, when you're testing out things, could be in a primary backup deployment. When you have larger scale deployments, then you need to consider orchestration, because then you will have many models across your company, and you need to good way to orchestrate and manage those. And based on the needs of your organization, for some private workloads, you may want to put them on-prem. Others you may be putting in cloud, so you have to do that analysis. From a resilience point of view, you want to have a robust endpoint which is serving your model. So it will be a microservice, or you're using a service like TorchServe, which is already exposing it as an API. So through that endpoint, you are serving your inferencing. Whether you are able to auto scale, so some settings will be needed for that. You will, if you're doing many models, you will need to look at canary deployments, so that when a new version of a model is rolled out, it does not have any adverse effects on the entire community. So you will test waters with only a select percentage of the user base. Same thing with A/B testing. Let's say you have a very different new type of a model. You want to compare and contrast with your existing model and see, is it giving you predictions are still aligned with your business goals or not. So you would do the A/B testing. And then when in the operations side, you will be doing the measurements to collect the metrics. You will analyze the model performance, look at things like interpretability, and have a continuous feedback loop for managing things. So on the responsible AI side, start by fairness by design. So here you will look at things like transparency, explainable AI. Does it have an inclusive design? You will measure the skewness of the data, measure things like is there a bias in the model, bias in the data, and identify the relevant metrics, which you will then continuously measure and monitor your models around. From a human-centered design perspective, you need to look at are the AI decisions having any kind of adverse effect on the people. So if you have a fully automated system and there is no human recourse for someone, so let's say someone applied for a mortgage application and the AI was rejecting people of a certain category, or people coming from a certain demographic, you do want to make sure that they have the ability to raise this and get some help around that. Similar things apply in the case of computer vision models. For example, based on the demographics, you want to make sure everybody's, regardless of their skin tone, their faces, etc., are recognized. So if they're coming from a different age group, your model was trained on this wide range of age groups so that there is no discrimination happening for the models. For the optimizations, you will look at the performance versus latency goals. Here, to reduce the size of the model, you will look at techniques like quantization, pruning, mixed precision training to reduce the size of the model. There are tools like the SnakeViz profiler that TorchServe provides. You will convert your models to Torch script for reducing the latency. And then you need to figure out whether you want to deploy it on a CPU or a GPU or a AI accelerator for low latency. And in terms of the endpoints, do you want to have REST-based endpoints or gRPC-based endpoints? So that analysis you will need to do. So on the quantization side, here are some examples of what we have seen inside Facebook. If you take a look at this translate fair seek model, when we converted it from a floating point 32 to an int 8 model, there was zero loss of accuracy. So this was using the technique dynamic quantization, and we saw a CPU inference speed up of 4x. So when you're deploying in production, these are important factors to consider and keep in mind. And this is the SnakeViz profiler, which comes along with the TorchServe. So what you see here is an example of a BERT model profiling in the eager mode, and the same thing in the TorchScript mode. So in the TorchScript mode, we are seeing speed up of up to 4x because of the serialization, deserialization overhead not being there. So this is a great tool to try out and profile your models before you deploy in production. Even if you're not using TorchServe, it's a great tool to give you these visualizations to understand the internals of your model. Then on the optimization side, for offline, you will need to think about whether you want to do dynamic batching or static batching. Are you going to have an asynchronous process with a push or a pull model for the actual service, which is going to invoke your machine learning, the model endpoint? Then in certain cases, it may be beneficial to pre-compute your predictions, especially if there are things that are not changing throughout the day, for example. So you could pre-compute them at night and save it in a database and use that. So this will speed up your actual microservices when you execute them. Then from a cost perspective, you will look at things like, do you want to deploy on a spot instance? So spot instances can be great, especially when you're doing offline predictions, where let's say even if a spot instance goes away, you could restart your offline prediction and still complete that within the time window that is needed for the responses. Then auto scaling, you will need to consider whether you want to do it on a metrics. You can have an on-demand cluster, what kind of metrics to use for auto scaling, and other aspects to look into for cost are use of a AI accelerator like AWS Inferentia for a lower cost point. So we support a wide variety of deployment models, on-prem, hybrid, cloud, and managed. So when you're in the develop test, you would often either install from source or do a standalone installation or do a Docker installation. And as you migrate up, you're doing staging and experiments. That's when you can deploy it on the cloud. You can use platforms like MLflow, Kubeflow, where we have integrations. If you're looking for a fully managed solution, you can use uh, AWS SageMaker or Databricks or Google, the Vertex AI pipelines. And when you're doing large scale deployments, you have to think about, canary rollouts, auto scaling, all these aspects. So from a resilience point of view, you need to create robust endpoints for serving. So here, either, like if you're on AWS, you can do a SageMaker endpoint. If you're on Google Cloud, you can do a Vertex AI endpoint. Uh, for auto scaling, you can, based on the orchestration deployment, you can auto scale. All these logic can be put in. TorchServe already supports multi-node deployment on EC2 and other scenarios. We talked about canary deployments. This is very important when you're testing the new version of a model. Make sure you're testing it out in a small subset of the user base before deploying it widely. And then another technique that we use heavily inside Facebook is shadow inferencing. So this is when you are building a new model, so let's say on a brand new architecture, and you're still learning things about that particular model. So you could be having a production model and you could have a shadow model which is learning from and then you can do a compare and contrast and iterate and refine your new model. So the models are running in parallel, both at the same time. And then A/B testing is for different versions of the model as you deploy them. Then from a measurement perspective, it will be good to come up with the performance metrics. So these could be as simple as accuracy, or they could be the fairness metrics that you identify during your responsible AI or fairness analysis. You can define any custom metrics on the TorchServe side and monitor those. If you are on AWS, you can use CloudWatch, or you could use Prometheus, which is cloud agnostic, and monitor the performance. For model interpretability, the explainable AI, TorchServe has an endpoint for explain, and the integration with Captum for model interpretability is there, so you can measure those. And you will need to have a continuous feedback loop to see if there is a loss of accuracy, or there's a drift, concept drift, or your model that was trained was the data has become stale. Now you need to retrain and redeploy the model if there is a trend change. So you will need to do those analysis. So this is what the typical loop looks like for fairness by design. So you start off by the understanding process, where you're looking at across the stakeholders. So these would be this will be a combination of technical, non-technical people, from the business, people from the legal, and all the impacted stakeholders, where you will come up with what are your goals of the product, what is the policy that you need to align with, does it have any impact on the users of different groups. So you need to have all that context. And based on that, you will align the discussions across the stakeholders and come to a consensus of, these are the, let's say, 4 or 5 things that we will measure. And this is how mitigation would be done in case something is off. So then you put in these measurements in place, and you're doing a continuous measurement analysis and mitigation and monitoring, and this loop continues. So this is the Captum for model interpretability. If you go to captum.ai, we provide many algorithms out of the box for attribution, interpretation. So these could be with respect to the output or with respect to the layers. So what you see here is an example of a zebra, image of a zebra, and the stripes of the zebra is what is attributing it in the image that it's a zebra. And in the question, the words that are important are highlighted in green. So I wanted to give a shout out to some of the interesting projects that are using TorchServe behind the scenes. So we recently launched our DynaBoard platform, which is a dynamic uh, benchmarking tool and a ML leaderboard for people who are submitting their models for scoring on this particular platform. So there is an active competition going on for the Flores 101 as part of the WMT competition. So this is for the large scale machine translation for low resolution languages. So please check this out. And if you're interested, participate in it. So when you submit a model for the scoring, you will need to, in addition to the model, you will need to provide your TorchServe handler for the scoring part. Then few other interesting community projects. Unity had created a solution for synthetic data generation for an end-to-end object detection pipeline, and it is using TorchServe for the serving of the models. There was a lady from Singapore, Saida, who created a very nice TorchServe dashboard. So this is for people who don't want to deal with the API for the management and deployment of the model. So very nice GUI she has built. So you can check that out. Then Vadwani AI is using TorchServe behind the scenes to empower cotton farmers. So they have an app where they are using to figure out if the pests have infected the cotton crop. So they take images and upload, and all the predictions are done on TorchServe, and the results are sent back. Okay. So in the future releases, we are adding more improvements around the memory and resource usage for better scalability. We are going to add a new C++ backend for lower latency models, which are needed for certain domains. And we are enhancing on the profiling tools. So I want to leave you with some references, and I will open it up for Q&A now.
Okay, thank you. Okay, sorry about that. Thanks for the presentation, very informative. So just to clarify, I guess to confirm, I think you mentioned this in your presentation, but gRPC support is available in TorchServe.
That's right.
Right. Okay. So that's been conserved. And then what about in terms of kind of, let's say if you're, you might have mentioned this as well, if you're making a lot of predictions, you think that prediction is something that'll, like that input will be kind of received again later on. How does caching work in terms of kind of if you want to cache predictions to serve them later on server?
Yeah, so it depends. If you're deploying it in something like Kubeflow pipelines, Kubeflow pipelines has built-in caching mechanism, and it takes care of this. So if the input is exactly the same, and it does that for both training side as well as prediction side. So based on the metadata tracking, it will identify if the same request comes in again, then it will just pull the value from the cache. But if you're not deploying in such an environment, then you will need to have your own database where, let's say you are making some predictions where certain things only change on a daily basis. So you don't want to be computing that every time. So you can pre-compute those at night, store it in your database and use that. But that will require you to put an additional logic in your fronting microservice, which will be invoking the prediction behind the scenes.
So that's something support that the developer would have to build themselves. I see. Right. And then in terms of kind of the like say pre and pro processing logic for request and response from TorchServe, how much customizability is available for that? Like how you can just input any like hooks into it, and
yeah, you can just it's a Python program, the handler, so you can invoke and write any code in your pre-process function, in your post-process function. So typically you would want to use the same pre-processing what you used in while training your model. So let's say your images need to be scaled to a certain size. You want to make sure when you are running the predictions, you are doing the exact same transformations that you used while training the model. Otherwise, your results will be off. So those are the types of pre-processing that you would be doing.
Right, definitely.
Yeah.
I guess in terms of kind of the maturity of TorchServe versus, let's say, TensorFlow serving, kind of maybe TensorFlow, they came out with more production-oriented kind of tooling before PyTorch did. How would you compare in terms of like feature parity now with like TensorFlow serving and kind of other, like the kind of TensorFlow?
So we've heard mixed things from people. So TorchServe is like a little over a year old. So our first release came out last April, and we are adding new features. We don't have a C++ backend yet, but that's something that we are working on. One of the things that we have heard from people in TensorFlow serving, you have to have separate components for pre-processing, post-processing. So you don't have this concept of a handler. So people like the concept of a handler that we have in TorchServe. At least that's what we have heard from customers who have tried out both, and why TorchServe appeals to them.
I see. And so is that what's driving your development? Is you're talking to kind of third parties? Mostly is it through kind of GitHub issues, or like how do you kind of respond to the community in terms of like the features that you add to TorchServe and PyTorch in general?
Sure. So this is a combination. So, definitely the GitHub issues that, the community posts, those are there. And then my team, we reach out to customers on a regular basis, and we are doing talks and trying to understand what are their pain points, and helping them get unblocked for the PyTorch side. So in those conversations, when we discuss about the production deployment aspects, that's when we hear war stories about the challenges that
Yes.
they're facing in production.
Of course,
Internally inside Facebook, we are doing trillions of inferences per day. So we are taking the insights from there, so many of the things, and we are continuously incorporating those into the new releases. So some of the features that came as a result of community and customer asks recently was support for ensemble models. So this is when you have a sequence of models that you need to call one after the other. So we have added a very nice example for neural machine translation that you guys can check out. So it does English to German and then German to English reverse translation. So it gives you an example of that. Another feature that we added was support for SSE encryption for S3 when you're loading your models from S3. So yeah, we encourage the community to reach out to us, open up issues on GitHub. If you feel that you require a deeper conversation and you have a niche use case, then please reach out to me, and we can schedule a more detailed conversation.
Certainly. In terms of kind of production side optimizations, so like let's say TensorFlow, at least you have a static graph that you can run some optimizers on. Maybe there's Onyx that you can convert to for. That used to be the way for if you wanted to do some inference type stuff. So how do you do optimizations for kind of TorchServe where you want to scale and maximize, let's say, utilization of your compute?
Yeah, sure. So we typically recommend people convert their models to TorchScript. So once you've built your initial version of the model, TorchScript your model, that will give you some level of efficiency already. Then you look at the techniques that I covered, like quantization, pruning, mixed precision training. So do all of that. And you're going to be using the profiling tools along with it. We recently released the PyTorch TensorBoard Profiler plugin as well. So now you can get a lot more detailed metrics and actual visualizations in that profiler. So
I see.
Use of these tools to understand the footprint and run that.
Right, and there's usually, I guess these, like, let's say if you want to do 32 or 16-bit precision for something, it's usually something out of a box that you can apply to any Torch, or like running TorchScript. That's something that you can use on any model or any bit of code, or is there kind of constraints?
So there are multiple techniques for this. The dynamic quantization, post-training quantization, and quantization aware training. Out of these, the dynamic quantization is the easiest to do. So maybe try that. So it's like a single line of code after your model is ready. Others involve you to do some iterative training. And you need to set up some hooks. So we have examples of that on the pytorch.org site. So please check those out. If you have questions, reach out to us. Yeah.
And in terms of a lot of kind of scalability and kind of let's say in terms of scalability, there's these third-party kind of libraries like PyTorch Lightning, which seem to have become very popular. It's kind of grew through the community. So how do you kind of decide which parts of like development, let's say in terms of serve, that you kind of offload onto like third parties, and like which ones that you do kind of in-house in terms of like, so how do you determine what should be kind of like within the scope of kind of what PyTorch kind of provides and what is kind of third party?
Yeah, so here we have a continuous review process on our side. When major features are requested from the community or what we are coming up with, we kind of evaluate that, what is the impact, what investment is needed. And based on quite a few criteria that we look at internally as part of our road mapping exercise, we decide, is this something that we want to build in-house? Or is it something that we want to reach out to a partner and build that? So actually, TorchServe is a good example of this. So internally inside Facebook, we have our own prediction service, which is very tied to our infrastructure. We wanted to provide a good serving solution, but it was not possible to open source what we had internally because it was too tied to our custom data center and other solutions. So here we partnered with AWS initially to co-create TorchServe and launch that. And now it is available on all major clouds. So we've done 14 integrations on top of the original TorchServe. It is available in every major cloud. We have added all these auto scaling and canary rollouts. We have also integrated it with the MLOps to open source popular platforms, MLflow and Kubeflow. So, yeah.
And this might be a kind of more simpler question, but in terms of kind of mini batching and batching when you're in production, how do you perform kind of batching? Or let's say if you need batch normalization in your weights and you have to kind of take estimates, and this is kind of like from a stream of data rather than, so how does do you get kind of out of the box mini batching like from a endpoint or something like that? Like how does that work?
Yeah, so on the TorchServe side, it is called dynamic batching. So you don't need batch normalization because that's during the training time. So with dynamic batching, you just have to set those two configuration parameters, the batch size and the max batch delay. It will automatically batch as many requests as the maximum timeout period of the max batch delay. So let's say you had 10 as the batch size and your max batch delay was 10. And in that time period, only 5 requests came. So it will batch 5. But if in that time period, 20 requests came, so as soon as 10 requests are there, it will batch those and send over.
Okay. Right. So I guess in terms of kind of the deployment and kind of the platforms that you deploy to, right? I guess PyTorchServe is more targeted towards the cloud right now. You can't target towards like edge devices like mobile. Or do you see that as part of kind of roadmap in the future?
So that's something that is coming. So, please look out for announcements from our side. On the mobile side, you will use PyTorch Mobile, which provides you the experience of how to do all the optimizations for mobile specific and deploy those. And I cannot say about the others.
Okay. Okay. Maybe you want a scoop. Maybe we get a scoop here, but Right. I guess in terms of kind of integrations with kind of ML flow, like how does TorchServe support work with ML flow, or like
Yeah, so we created a plugin for ML Flow TorchServe. So it's a command line plugin, and you can also call it programmatically from Python. So we did all that integration. So that's available with ML Flow. Same thing with on the Kubeflow side. We integrated with KF serving, the KF serving API. So that's when we also added support for explainability. So both the predict and the explain endpoints are available.
right.
So you can just call from there.
And I think you mentioned something kind of very interesting, which was kind of a TorchServe handle that you could submit, let's say for peer review. Like if you have a paper, you can also submit a kind of like an endpoint or something like that, like a TorchServe endpoint. Is that something that you've kind of thought about scaling, let's say for research? Like if you're submitting to a conference, like reproducibility is always a big question, and not having access to let's say there's compute constraints for being able to reproduce someone's work. Is that something that you've thought very deeply about, or?
Yeah, so that's an interesting angle. So definitely it can be used for that purpose as well. So our Fair Research recently launched a ML competition leaderboard. So this is targeting for the natural language NLP related tasks. So if you go to dynabench.org, so that's the competition site, and we just launched a leaderboard on that. So now when you submit models to that leaderboard, in addition to your model code, you will submit the TorchServe handler for scoring of the model. And the first competition that is going to use this is the Flores low resolution competition as part of the EMNLP. I think that results will be announced in November, but the competition is open now, so anyone can go participate.
Right. So EMNLP is a pretty big conference in NLP. So I think it'll gain wider adoption once it's kind of been tested.
That's right.
I think that'd be a very interesting development in terms of reproducibility for sure. And I guess in terms of kind of the distributed side, the communication side, if you have multiple nodes that you're passing gradients between and kind of doing distributed optimization, what are the kind of the support for, like, let's say if you have gradients, you want kind of sparse gradients or, some kind of compression. Is that available right now out of the box with kind of PyTorch, or?
Yeah, so that is a question on the main PyTorch side. Yes, we have added many of these optimizations. So we just released Power SGD is one of the algorithms that we support for gradient compression. If you go to our pytorch.org and just earlier this week we launched 1.9 release, so please check out the release notes. We have launched many new features on the distributed training side for the optimizations, and there is also a library called Fair Scale from our Fair Research, where we put out some of the cutting edge new features, so you can check out. So the full sharding VFSD algorithms are available over there. And we also partner with other partners like PyTorch Lightning to make it easy for people to do all of this. So there, you just pass a command line parameter, and a lot of this, all this is taken care of behind the scenes. So you don't have to worry about a lot of these optimizations.
I see. I guess kind of one last question, maybe directed towards kind of like the AI and fairness side of things. So I guess, can you talk about a little bit more about like the process in terms of kind of like determining like certain goals or objectives, and how kind of like as an ML practitioner, are you someone that has kind of feedback into that process, or is that something that's kind of top down determined, and then you have to kind of implement like certain kind of goals or values? Like how does that work in terms of like input?
At Facebook, it is a engineers organization, so there's nothing top down. A lot of many things are coming up, ideas are coming from the engineering side. We do have a fairness maturity model that we have identified, and we are in the process of rolling it out across a wide range of our models internally. So some of the, like Captum interpretability is one of the tools that we open sourced. Then we have similar things coming out on the federated learning, differential privacy side. So Opacus and Krypton are other tool libraries. And we are soon going to add support for model cards and more fairness metrics as part of our core offerings. So you'll start to see more features coming around in that area from us.
Right. I mean, that's certainly exciting. For one thing, I think like the evaluation of models is sometimes very restricted, particularly if you're kind of targeting towards benchmarks on kind of conferences, kind of these standard benchmarks. That does not a full evaluation of the model. There needs to be kind of richer features that are looked at in terms of kind of bias in these things. So that's very interesting development in that direction. I would like to thank you for the lecture. I guess if everyone wants to follow up, what are some follow-up link or follow-up kind of resources?
Sure, I will drop them in the chat. You can reach out to me on LinkedIn, or you can reach out to my contact me over email. Either option should be fine. If you have any specific questions for TorchServe, please open up GitHub issues on the TorchServe repo. Specific questions for PyTorch, same thing, PyTorch GitHub, or on our Discuss channels.
Okay, well, thank you very much, Geeta. I'll end this presentation. Okay.
Yeah, thank you, Ali. It was lovely chatting with you.